Hello everyone, welcome back to our new video on Booth's algorithm represented by Group J2. Myself, Sresh Khamkar. We are 6 members in this group. That is Atharva Khaire, roll number 7, Prasad Khambatkar, roll number 8, Ayush Khambaite, roll number 9, myself Sreyash Khamkar, roll number 10, Deep Khanchandani, roll number 11, and Om Khandare, roll number 12. So let's start our presentation. In this presentation, we are cover 5 to 6 topics related to Booth's algorithm. First is introduction about Booth's algorithm. Second, history of Booth's algorithm. Third, step to be performed for solving the example. Fourth is example with its solution. 5. Application of Booth's algorithm. So now I am telling about introduction to Booth's algorithm. The Booth's algorithm is a multiplication algorithm that allows us to multiply the two signed binary integer in two complement respectively. It is also used to speed up the performance of the multiplication process. Another information is it is multiplication algorithm with the ability to handle negative number, reducing the number of partial product and being useful in the digital circuit. Also, Booth algorithm is a fast and efficient method for multiplying binary number that are well suited for hardware implementation where speed and efficiency are important. Next, Om will be continue.
So hello friends, my name is Om Dinesh Khandare and my roll number is 12. So we will going to see the history of Booth's algorithm. Let's get started. So Booth's algorithm is a multiplication algorithm used to multiply signed binary number, means two binary numbers. It was invented by Andrew Donald Booth in 1950 while he was studying at the Birkbeck College in London. Before the Booth's algorithm, the most common method multiplying the two binary numbers was to use the standard long multiplication method, which involves multiplying each digit of one number by each digit of another number and then adding the products together. This method was especially large numbers as it requires a lots of calculation and was prone to error. So Booth's algorithm improved on this method by reducing the number of operations needed to perform the multiplication. The algorithm works by examining adjacent pairs of the digit in the multiplier and shifting the multiplicand left or right. It depends on the value of the pair. If the pair is 0, 1, the multiplicand is subtracted from the product. And if the pair is 1, 0, the multiplicand added to the product. If the pair is 0, 0 or 1, 1, no operation is needed. That's why the Booth's algorithm is particularly useful for the multiplying large binary numbers, as it could reduce the number of operations reduced by up to the one-third compared of the standard long multiplication method. It was also early computers to perform binary multiplication operation. However, as the computers become more powerful, faster algorithms were developed and Booth's algorithm fell out of the use in modern computing. So this is all about the history of the Booth's algorithm.
So hi friends, my name is Ayush Kiran Khambaide and my roll number is 9. So till now we had seen about the overview and the history of Booth's algorithm, and now we are going to see how the Booth's algorithm can be performed using the following steps. So let's see steps as follow. Steps to be performed. The first step is initialize a q minus 1 to 0 and count to n. So we will understand from the following image, that is, based on the values of q0 and q minus 1, do the following steps as follows. So first of all, we have to initialize a as 0, then q minus 1 as 0, b as multiplicand, q as multiplier, and count as n, as shown in the figure. So what the point A says, if q0 and q minus 1 both are zeros, then write shift arithmetically and finally decrement count by n. So if both the values of q0 and q minus 1 are 1 1 and 0 0, so directly we have to shift arithmetically the binary number, and then we have to decrement it by minus 1. What the point B says, if q0 and q minus 1 are 1 0, then add a and b stored in a. Write shift a and q0 and q minus 1 and finally decrement it by minus 1. Then what the point C says, if the values of q0 and q minus 1 are 0 and 1, so we have to add it such that we have to do the following operation as a plus b, and then we have to arithmetically shift it and decrement it by minus 1. Hope you can understand the following. The next step is, if q0 and q minus 1 are both 1 and 0, or if q0 and q minus 1 are 1 1, then arithmetically shift it by right and finally decrement it by 1, as I said in the following slide. Now repeat step 2 till count does not equal to 0. Using the flow chart, we can solve the given question as follow, such that minus 5 into 10 into minus 5 into 10. So the binary number will be 1011. We have to do the 2's complement. So the multiplicand b will be 1011 and the multiplier q will be 1100. And initially q minus 1 is equal to 0 and count is equal to 4. So such that we can solve any question using the Booth's algorithm. If we take the following example as minus 5 into 10, so the answer we will know as minus 50. Using the Booth's algorithm, we can convert it into the binary number and we can solve using this flow chart, and we will get the answer as minus 50. Thank you.
As you saw that what are the steps that we need to consider while performing the Booth's algorithm. Now, before performing that step, there are basically two conditions that we need to fulfill. First is that we need to decide that which operand should be multiplier and which operand should be multiplicand. Now, to use Booth's algorithm, you should represent both multiplicand and multiplier in signed binary form. This means that the leftmost bit represent sign of the number, with 0 indicating that the number is positive and 1 indicating that the number is negative. Now, once you have your signed binary numbers, you can apply Booth's algorithm to multiply them. The algorithm works by repeatedly shifting the multiplier to the right and checking the last two bits to determine whether to add or subtract the multiplicand. Now, in general, the value of x bit should be chosen to accommodate size of the largest operand being multiplied and to allow for the sign bit when using 2's complement representation. So now let's take an example of 7 and 3. Now the numerically greater operand is 7, which would require at least 3 bits in binary to represent it. But so which means that the x bit should at least be of 4 bits so that the first bit will represent the sign of 7. So you can see here we have taken 7 as multiplicand and 3 as multiplier. Now this is the table. So multiply 7 and 3. Using above signed 2's complement binary multiplication. 7 is multiplicand whose binary equivalent is 0, 111 and is represented by M. Multiplier is 3 and its binary equivalent is 0011 which is represented by Q. And these are the steps.
So hello, I am Atharva, roll number 7. I will continue. As a Prasad explains you a required steps to perform binary multiplication using Boost algorithm, I will explain the example using these steps. Here we have a table in these 5 blocks where A is accumulator register, Q is multiplier, this one is for quotient bit register, this action, and this for a counter. We will perform a operation up till counter is 0 as shown in this table. When counter is 0, we exit from this program. Here 7 is a multiplicand and 3 is a multiplier. We perform all the operation using a combination of LSB of multiplier and a bit register. When the combination is 1 0, we will perform first subtraction operation which we save in accumulator, and after that we will perform a arithmetic shift right. Um, as same when the combination is 0 1, we first perform binary addition and this save in accumulator, and after that we perform arithmetic shift right. If we have a combination as a 1 1 and 0 0, we directly perform a arithmetic shift right operation. So as a performing all the operation, here such example when the LSB is 1 and the combination of this one is 1 0, we perform first arithmetic subtraction, and after that arithmetic shift right. Here when the combination is 0 1, we first perform a addition and after that arithmetic shift right. We perform this operation up till the counter is 0. When the counter is 0, we have a answer. When we converted this binary bit into decimal, we got an answer as a 21, which is a required for which is required. uh, so thanks.
So hello friends, my name is Deep Khanjandani, roll number 11. So now we are going to see the applications of Booth's algorithm. Let's start. The first one is digital signal processing. Booth's algorithm is widely used in the digital signal processing applications, such as in the digital design, filters, and other signal processing circuits. The second one is cryptography. Booth's algorithm is also used in the cryptographic algorithms, such as in the RSA algorithm, which is used to encrypt and decrypt data. The third one is computer arithmetic. Booth's algorithm is also used in the computer arithmetic, where it is used to perform fast multiplications of binary numbers. We had finished with our topic, that is Booth's algorithm. So hope you like the video. Share, subscribe and like our video. Thank you so much. Thank you.